Everyone's
Yeah.
What's your name,
You're
Tyler?
gonna, I do this, you're flying this way.
I was kind
You're
of
not
expecting
gonna start now, you're far. Land,
Yeah.
so don't jump here.
Oh, I see.
Fly, parachute, control.
One more, there's one more thing that I want to talk about as far as Siemens, and then we're going to shift gears a little bit and get you into something different. The plan is to get out of here a little bit early.
quick math. Quick math.
Communications,
It's a quick math.
so PLC communications.
Oh, you want to get
This is wide load now.
In the Siemens world, we use Profibus. What's the other one?
One profit right.
Profinet, yeah. You guys have been around this stuff. And Profinet. And these are Siemens developed communications. Profibus, it's based around RS-485 communication protocol. Profinet is based around Ethernet. So we'll use the Profinet port that is on the front of the simulators or the trainer, but it's all Ethernet. It's just like Ethernet. Profinet is an industrial type Ethernet.
It's gotta be different.
That'd be different. Profibus is more of a legacy type of communications that Siemens uses, and it's more for like remote I/O type stuff. And here's the thing: this Profibus, it's very, very, very similar. You see the communications protocol, RS-485. It's very similar in the Allen Bradley world as the RS-232. Allen Bradley called that DF1, if you remember. Remember we set up a DF1 driver?
Yes, we do.
That's very, very similar. It's old and slow. And then, of course, Ethernet, same stuff. Yeah, Allen Bradley world. So just to give you an idea, what do you guys use, Josh? Profibus. Profinet's kind of what everybody's going to, since it is faster and more reliable. To give you somewhat of an idea,
Kind of feature all, I think we're pretty much.
That's been different.
that'll make sense these days. Here's kind of the differences. There's really not many similarities to the two. Profibus on the left, in the left-hand column, you see the speed is 12 megabits per second, where Ethernet, it uses, or Profinet uses the Ethernet protocol, a gig per second, or 100 meg per second, so on. This RS-485 stuff, the Profibus, you see it has this master-slave stuff. So what happens, it slows it down because there's this one manager, PLC or hub or switch or whatever's managing communications. It sends out tokens to these other devices saying, yep, there's no traffic, it's your turn to talk. It's your turn to talk. It's your turn to talk. So there's one manager in this RS-485 communications. You can see how slow it can get if there's a lot of devices trying to get back to the PLC. A lot of remote I/O. The Ethernet, of course, it doesn't matter as long as you have a different IP address.
Error 404.
What is that thing?
the page could not be found.
Oh,
I think 400 is like, the server is down or something like that, I don't remember.
but anyway, just to give you an idea of what's going on there. You hear the terms Profibus, Profinet, nobody knows what they mean.
I'll let DLC
There you
do that
go.
for you. I'll let DLC do that to you for me.
The next thing we're gonna do, something that we haven't gotten to, that's, I think is very important for you as maintenance people, is actually troubleshooting using a PLC, when you get online with a PLC and troubleshooting, because you've been around these guys that are in maintenance, they get online with a PLC, and they're paging through all these subroutines, paging through all this stuff. And half of them don't know what they're doing. So, but I'm gonna show you a methodical approach of fixing things using a PLC. I know it doesn't mean anything right now, but let's go back into the hardwired world of troubleshooting. So hopefully this is kind of somewhat a refresher. So yeah, maybe some of you don't have a clue, and that's fine too. Let's just say, for example, let's say we have a hydraulic lift table. This is a solenoid that runs a valve, that shifts a valve for this lift table. Lift table won't lift. This solenoid is not being energized. You go out to the machine and you look on the solenoid, the light's not on. Right? Where do we start troubleshooting this thing? How do we start troubleshooting this thing?
Look at the prints.
Huh?
Look at the circuit.
Look at the electrical prints. Yes, absolutely, right?
Check the troubleshoot.
And where are the electrical prints normally at?
In the cabinet.
In the cabinet, in the panels, in the electrical panels, right? Unless somebody used them and didn't put them back.
Then you have to beat them with the prints once you find them.
They used to tick me off so bad. Put them back where they belong.
And you irritates me. It's like, where did those run off to?
So you start going through the electrical prints and you run across this line of logic right here. Where do we start troubleshooting? And here, your electrical prints are generally going to have, what are these guys?
Numbers.
Let's see.
That's gonna be terminals on your relays.
Terminals on the relays, that's exactly right. Generally, your electrical drawings are going to have those. They should have if the machine builder did his job right. Probably don't.
They're not
So
always
if-
the relays that we use. Ours don't have them just because of the relays that we use.
So we're in the electrical panel. We have the set of electrical prints in front of us. We see this. We see that we're not energizing this solenoid for this hydraulic valve. What do we do?
Start the cell going to work backwards.
Yeah, here's the first thing we do. We're in the electrical panel already, right? Where are these relays going to be?
In the panel.
They're going to be in the panel, right? So you can do a visual, right? That's the first thing you want to do, a visual observation to say, okay, well, CR3 is energized. You look at it, it's pulled in, right? Or the light's on if it's an high-speed relay. CR3 is pulled in. And so you can pretty much assume that that contact is closed, right? And then you say, CR2, what's the state of CR2 have to be?
It would have to be.
Have to be.
What about the relay coil itself? What state does it have to be? Right, de-energized. So you look at CR2 and make sure it's de-energized. You look at CR1, it's energized. So right there, you haven't even picked up a meter yet, right? You don't need to, you see these guys run out to a cabinet with a meter in their hand. Most of the time, you don't even need a meter. They want to look like a hero, right? You've seen them grab a meter real quick, run out to the panel and open doors. They've wasted a lot of time grabbing their meter and all this stuff when they could have already eliminated a lot of things. And it's all about money, right? Let's say we, where do you usually start though? Let's say CR3 is energized. CR2 is not energized. CR1 is energized. What's your next step? You don't want it, you don't know where this proc switch is. It might be down in a pit somewhere, or it might be 30 foot up on a mezzanine somewhere. You don't want to run up.
CR1 to 3 is, I mean, it's getting power.
When you check the place at
We check the midpoint, right?
Check the point of,
You guys,
drops in the panel.
You check the midpoint, if it's good, check terminal 3, you can work back towards the switch.
that's right. Let's say our midpoint's here, somewhere on the midpoint. Then we start measuring, right? You don't want to run out to this proc switch. You don't, like I say, it might be down in a grease pit somewhere, you know? Unless you know the machine really well. So we start measuring. When we start measuring, what do you always reference? Always, always, always reference round for common, right? Exactly right. Because what's gonna happen, and you've seen these guys do it, they'll take a meter and go here. What does that tell you? You have no reference. No, you don't have a reference, right? So you have to start at a reference and work your way. You always use a reference or a ground. Make sure you got a good ground that you're using. Don't just go up and go, right?
Like when he's
You're
right to
wasting
the edge of the
time.
ladder.
Huh?
Right on the edge of the ladder, like it's not doing anything.
Exactly. And you get all kinds of weird voltage readings too, don't you? Like 60 volts, 30 volts, oh, where's that going from? You know what I'm saying? I've seen guys do it.
Did you?
They have a meter in the panel and they're just probing it.
That's what I was in my first semester.
Okay. So let's say we measured this point and we get 0 volts. This relay is energized. What's the probable cause?
You could either have something wrong with the relay or a broken wire.
Yeah. And another thing about your electrical prints, which is your roadmap, very good clue,
They have labels.
is any external devices, external from the main panel, from the electrical panel, what do they have to do? They have to come in the panel and land on a terminal strip, right? The wiring by code has to land on a terminal strip. So your drawings will more than likely, they should, have a terminal number where this thing's terminated at in the panel. You open up the panel, you see all the terminal strips in the panel, terminal block. Look in your drawing, and we haven't even gone out to this switch yet. We don't care yet. Now we're going to measure up to this point. We're going to measure the terminal block, the terminal strip that it's coming in on. So you've eliminated everything inside the panel, pretty much. Does it make sense? Yeah, you avoid wasting a lot of time by just doing careful observation of things and being very thorough about doing it. But the point is, in the PLC troubleshooting world, in the electrical hardwired world, we start somewhere in the center and then measure back. In the PLC troubleshooting world, we start at the output. Because if you start in the middle somewhere, you're going to be lost. You see all this ladder logic, all this stuff. So we're going to go through some of those right now. And practice a little bit. Open up the 172 folder, IMT 172. There's a folder called Allen Bradley Programs out there. Yep, Allen Bradley Programs, Slick 500 programs, that's our Slick 500 program. And let's open up HX2259.
Just the first training one?
Yeah, yep, HX. It'll say, hey, do you want to work with a copy or something? Just say yes.
It says split 500 and then what?
File is currently open on the
Yeah.
Which file is it?
HX 2259 training.
22.